computer. Okay. So today we are supposed to start with a new chapter, and I believe it's chapter 6. I went through chapter 6 and I found out that chapter 6 and chapter 7 are all about object-oriented programming. And I looked at how the book decided to divide the concept of object-oriented programming into 2 chapters. And to be honest, I am not a big fan of how the book is handling this situation. I think the way that the book decided to break down object-oriented programming into those 2 parts and separate them is not the best way. For a simple reason is that when you want to know and learn about object-oriented programming, it's a good idea to have a good idea about the whole thing and then add a little bit details to it. Like have a good idea about the concept in general, and then with time, keep adding details to it. But what it looks like, the book that we're using decided to break down the whole concept into 2 equal parts. So if we go with the book, for example, we're just going to cover the first part, and you will be left with a lot of questions and a lot of things that may not make any sense to you, and it will make sense when we cover them in the next chapter. So for that reason, I am going to stick with the book. Don't get me wrong. I'll stick with the book, but I am just going to leave the PowerPoint and leave the book on the side for a while. And I'm going to focus on introducing the concept to you to have a good idea about what is object-oriented programming in general. And then after that, I'll go back to the book and go with the way everything is organized. So with that being said, let me just go straight to the course page. And this is not it. Here it is. This is chapter 7. If I go to the modules, and if you go, this is the PowerPoint file, you can download it. But what I did here, I uploaded this file here, Understanding Object-Oriented Programming Concept with a Smartphone. So this file, what I want you to do, you can download it and have a look at it, but I'm going to go through this file and I'm going to explain the concept in general. Hopefully, by the time I'm done using this file, you'll have a good idea about what is object-oriented programming and how does it work. Let me stop my video first. And let's go, and I'm going to share my Word document. Where is it? It's minimized. Let me just maximize it first. Let me restart now. For some reason, it's asking me to restart that file. And let's see here. I'm just going to have to wait for it to open again. Come on. Okay. And now it's opened. And let me share it. 1 sec. And here it is. Okay, so first thing first, we need to have a good idea about what is object-oriented programming before I actually get into it. Just as a very simple, what is object-oriented programming? Well, here's the thing. So far, everything we have been doing in this class is called procedural programming or style of programming. And procedural simply means when you have a problem and you want to solve this problem, you simply think about the solution as a sequence of steps that you have to follow, or a sequence of instructions that you have to follow in a logical order to solve the problem. So if you go back to all the labs, all the assignments, everything we did in this class, take the Sarah Lemonade project as an example. What we did, we simply thought about the whole thing as, okay, I need to create my variables. I'm going to store the values in the variables, and then I'm going to perform these calculations, and then I'm going to show the results on the screen. So you think about it that as a sequence of instructions that you wrote, and the computer is simply going to execute these sequence of instructions. And at the end of the program, by the time the program is done executing, you get the problem solved by getting the outputs that you were looking for. That's again what we call procedural style of programming. Object-oriented programming style is a totally different method of solving problems or writing a project for that matter. With object-oriented programming, what we do, we simply think about the whole problem in a form of objects interacting with each other. That's, again, what is object-oriented programming is all about. So instead of me thinking about, oh, I'm going to create a variables for the following measurement, and then I'm going to perform these calculations, and then I'm going to show the results with this sequence of ordering. If you go back and try to think about the Sera project that we covered before, how would I think about that in an object-oriented way? Well, here's what I'm going to do. I'm going to create an object, which are the lemons. So lemon is going to be an object. And then I'm going to create another object, which is the glass. I'm going to create another object, which is the pitchers. And I'm going to create an object, which is the person who's selling them, which is Sarah. So as you can see here, I didn't think about the solution in a form of variables and arithmetic operations and show me results. I'll put that on the side. I look at the problem as a group of objects that are going to interact with each other to get something done. So we look at the problems in that format, objects interacting with each other. That's what object-oriented programming is all about. If I want to take the room that I'm sitting here right now, the room by itself, it's an object. The computer that I'm using is an object. The disk that I'm sitting at is an object. I'm an object. The glass of the water that's next to me is an object. So instead of us thinking about the solution in a form of steps, we think about the solution in a form of objects interacting with each other. For example, Sarah, she's going to line up the glasses. She's going to squeeze the lemons to create lemonade in those pitchers. And then she's going to go and put the lemons inside those glasses and start selling them. Sarah, as a human being, she's going to be doing the calculations to figure out, not the calculations, simply based on the number of objects that she has, how many pitchers she has, how many glasses she want to sell. She will be performing the calculation to figure out how much money she's going to be making. But all of that, again, it's done in a form of objects interacting with each other. And that's the concept in general. What is object-oriented programming? Is simply thinking about problems in a form of objects interacting with each other to get any specific problem solved. And that's, again, what object-oriented programming is all about. Now, this is, again, a very, very simple, easy definition of the concept, but there's a lot of details that goes under the concept of object-oriented programming. And today we're going to have an idea, and I want you to work with me here. So I want you to pay attention to what I'm going to do here. What I'm going to do here is, I don't know. In this example, I was supposed to use my phone, but which I don't know where it is. So I'll let that to go. Here's the idea. For example, in this Word document, I want to use a smartphone as an example to explain object-oriented programming. But before I jump into that, there is one concept that I need to clear before I show you the example here. In object-oriented programming, we write classes and we code classes, and those classes gonna produce objects. That's a very, very important concept to understand. As a programmer, you are going to write and create classes. Once you're done with creating the class, you can create objects out of that class. That's something you have to understand from the beginning. I want you to think about classes as a blueprint for the design of the object you want to come up with. And let me just give you an example here. For example, for engineers, a company, for example, producing cars. So before they start and jumping into the process of creating the cars, they're going to design the car. So the engineers are going to be sitting on big tables with those blueprint papers. And what do they do in the blueprint papers? They simply describe every single detail related to the cars they're going to be producing using that design. So classes by themselves are considered as the blueprint. An object is the final product using that blueprint. A lot of times I found a lot of students, they don't know how to distinguish between those two concepts. You start by writing the class. The process of creating the class and writing the class, it's the design process. It's the place where you're going to decide how many doors I'm going to have, how fast the car can go, what kind of operation this car can do. It's all about you describing and designing the car using the blueprint. Once you're done creating the blueprint, that blueprint is going to be taken to the manufacturer, and they're going to simply use that blueprint to produce cars. Okay, so now we know what is a class, and then we know what's an object. And I'm going to demonstrate that with real examples later, but it's a good idea to, yes.
So like I learned Python, and like how does this like relate to Python? Is there anything like that in Python?
It's kind of very similar.
Yeah.
It's very, very similar to Python. So it's just going to be a different when it comes to syntax.
Okay.
It's going to be a lot different when it comes to the syntax. Let me just be clear about that.
Okay.
I'll be honest. Like I learned object programming in Java and C++ and Python. For some reason, which I don't know why, I like it better in Java and C++ better than Python for some reason. But again, it's something personal. Let me just put it that way. Okay, so let's get back to this example. What I'm going to do here, I'm going to be asking you questions, and I'm going to answer those questions, of course. But let's just imagine we want to create an object. And this object is a phone, a smartphone. So before we create the object, let's talk about the phone itself, the smartphone by itself. And what I'm asking you here, that I want you to identify and give me 10 properties you can use to describe a phone. Now, here's the thing, which is, again, very, very important to understand. I am not asking you to give me values for a phone. I'm talking about properties. So when you talk about a phone, you will say a phone, for example, has an operating system. A phone has a color. Okay, but what is the color? What is the operating system? This is not my business. I just want to know the attributes that I can use to describe a phone. And I'm going to go with a list that I'm asking you to do with 10 of them. I can say a phone should have a color. And I can say a phone should have an operating system. A phone should have a size, screen size. Let's put it that way to be more specific. Screen size. A phone should have the properties that I can think about a phone, which is the resolution. Operating system, brand. That's a property for a phone. Let's say, what else? Color, operating system, screen size, resolutions, brand, storage. Storage. A phone should have a memory. And by the way, the memory, I mean RAM. And this simply a permanent storage device. What else a phone should have? Okay, let me just open the chat, and I want you guys to suggest stuff to me. What else I can use to describe a phone? What else properties? Battery life, here we go. How long? Weight, of course. And SIM cards.
Simplicity.
Yeah, that could be it. Screen material, LCD, OLED. Okay, that's also a good one. So see here, you guys are coming with a lot of examples, which again, every single phone will have a SIM card. Oh, I have an idea. Every phone should have a phone number. Now, again, thank you for all these suggestions, and they are all acceptable, but let's just stick with those 10 properties that I have here. Okay, so let's just focus here. Those are properties that we can use to describe a phone. And as you guys suggested, there are way more than just those 10 properties. So we can add them, of course, if we want to, but this is, again, what I was stuck with at this point for simplicity. Now, when you think about each one of those properties, I want you to think about them as what we call a data member. Okay, every one of those properties is a member inside the class that we're going to create later. Network interface cards. Yep. So, for example, the color is a property for the phone. The operating system is a property of the phone. The screen size. But again, I want you to pay attention to what I'm doing here. Did you see me or hear me mentioning any values? Like, what is the brand? Apple, Android? No, I'm not. Pixel. I'm not talking about brands as values. I'm not talking about the screen resolution, the screen size, or how much storage. Or no. That's not my business at this point. All I care about is the property itself. This is the phase of the design of the class. Think about these properties. Now, when it comes to the second part here, step 2, I need to have a description for each one of those properties. And when it comes to the description, I simply need to understand, and since we're talking about programming here, when it comes to colors for a smartphone, if I want to put that in a form, how do you describe a color in general in programming? You can create a string, and you can call the string color, and then after that, you assign a specific color to that color string. Operating system could be a string as well. The screen size, again, could be a string. The resolution could be a string. The brand could be a string. Storage, I can go with integers. Memory, I can go with integers. Battery life, I can go with integers. The weight, I can go with doubles. Phone numbers, I can go with, I'll go with a string as well. So each one of those attributes you can see here could be associated with a data type. And it's going to be your decision, again, it's a design issue here, that you're going to have to choose the right data type for each of these properties or attributes. So, for example, I can come here and say color is going to be a string, because after all, I'm going to assign a specific color to it. Now, here's the deal, and I want you to pay attention to this part. When we're going to create a specific phone, and I want you to think about that again. When we're going to create a specific phone, let's say we decided that we're going to create an Apple phone. One of the things that we know about Apple will always give us a limited number of colors to choose from. Okay, so what will be the mechanism that we are going to use to decide which specific color should be assigned to a specific phone? I hope this idea here is like working in your head a little bit. So in general, I'll give you this right now. When you create a string and you say the string is going to be a color, you can give the user a full freedom to choose whatever color he want to choose for his phone. For example, think about this application here as an employee who's sitting in front of a computer taking the wish list from a customer about what kind of phone does that customer wants. And you're filling the form, so it's going to be manufactured later. So you can ask the user to tell you what the phone that he wants, and the user can come with any color that he would choose. But the question is, will Apple, for example, allow that? No, Apple has a limited number of colors. So we have to think about something extremely important, which is who has control over what value should be assigned to each of these attributes. That's a very, very important question. And to answer it, it's you, the person who's creating this program, should have full control over any value will be assigned to any of these attributes. And the reason why you need to have a full control over it, because if you leave it to the user may do some stupid things that will crush your program, or may do some choices that will not be executable. So we will set, and we'll see that later, we will give the user some sort of freedom to choose the values that he wants for his phone, for example, but his choice is simply going to be controlled by you. So if the user made unacceptable choice, you go and tell the user that whatever you did is not acceptable, and here are your choices.
I have a question.
Go ahead.
Is this like input validation?
Is this what again?
Input validation.
I would not say input val. It could be in that range of input validation. But here's the thing: when you ask the user for a color, okay, and the user decides to go with red, and color red is not option here. It's very similar to the concept of input validation, but I would not call it input validation. Usually input validation, when you ask the user, for example, to enter an integer and he just enter a character or a value out of range. But in general, yeah, it could be considered as input validation.
Okay.
Okay. So as you can see here, you can go for each one of those values. For example, operating systems. We know that we have only 2 operating systems. It could be an iOS or it could be an Android. Imagine, and we used to have a third one, which is the Windows phone operating system, but let's just be realistic in what we have these days, which is Android or Apple. Now, let's say you decided to give the user a choice. Okay, what kind of operating system that you want? And he decided, well, I want to have my phone with a Linux operating system. Of course, that's not acceptable. So again, you don't want to have the user to have full control over what values will be assigned to those attributes. You want to have that full control with a little bit of windows to let the user choose from, let's say, a list that you provided with. So instead of me going through all of that, I would just stop at this point when I talked about the string as a color, and that simply is going to be applied to all of them. Battery life, how long you want your battery to be, how heavy you want your phone to be, what phone number that you want. So all these properties, again, remember, we haven't assigned any values to them. All we're thinking about here is the design of the phone in general. So once we're done with the attributes, now we have to ask ourselves, well, this smartphone should be able to do something. So what are the things that a smartphone can do? I can tell you here, can make calls, text, take pictures, make calls, take pictures, text. What else we can do? We can run apps, and then we can make, let's call this one voice calls. And we can make video calls. Make video calls. Of course, again, if you think about it, really, all of those are simply running an app, making a voice call, a video call, taking a picture. What are you complaining about here? Okay, he didn't like the uppercase video. So here we go. So those are what we call actions that the phone can simply do. Now, to be very, very specific, we call them methods or behavior. So a behavior simply is what the phone simply can do. And every one of those behaviors, again, will be implemented. Like when you want to make a call, you're simply calling that behavior, or you're calling that method. When you want to write a text, you're calling the method that will generate the text and send the text. When you want to take a picture, you're simply calling the method that's responsible of taking the pictures. So each one of those behaviors and actions, a phone simply will be able to do. Now, so if I just come here and just try to summarize what I did, for you to be able to create an actual product of a smartphone, you need to create the class of a smartphone at the beginning. And the class of a smartphone will simply contain 2 main things. The first one is what we call the data members. And the data members is a list of properties or attributes that describe what that class is. And then we have a list of what we call method members or behaviors. And method members is simply what can that class do. So the attributes describe what it is, and the attributes describe what can it do. And this is what classes are all about. And then once you're done creating the class, you can immediately jump into creating objects out of that. At this level, we're not going to get into the details of how objects interact with each other, because that's a little bit advanced. And I believe you guys have a class after this one that is simply going to be dedicated to study the relationship between classes and objects. So I don't want to jump into it because it's as I said, a whole semester by itself. But for today, our main objective here is just to understand the concept of a class and what it is, and the concept of objects and what they are. So before I continue, is there any questions? Are there any questions?
Can you explain behaviors again?
Behaviors again. I'll tell you something. If you take each one of those points that I have, the 5 points that I have here, those are again operations are going to be implemented. Now, here's the thing: when I talked about the color of a phone, I'm simply, again, it's a color. It's a piece of information. It's a red, it's a green, it's a blue. That's the attribute with the properties. But when you're going to call a method and we're going to create a method, the method will be implementing something. It's going to be performing something. For example, let's take sending a text message. Sending a text message goes through many, many complicated operations. Your job as a programmer to list all of that inside the text method. Okay, and I'll just give you an example here. Your text message simply is going to start with a text editor where you're going to type the text. The text is simply going to be send that text to what we call the transport layer. The transport layer in the networking systems is simply going to be responsible of deciding if I'm going to send the data in a reliable format or unreliable format. All of that is going to be done in a program. And then after that, well, after you decide the reliability of the method you're choosing here, you go and think about, okay, the other phone that I'm trying to communicate with has an IP address. What is that IP address? How am I going to get it? All of this that I'm talking about, you're going to have to write code for it. So you see here, with attributes, it was just the process of deciding that the color is going to be red or green. But the methods, you have to write a program that will actually get something done, which in this case, texting. Did that help a little bit?
Yeah.
Okay.
I have a question.
Yes.
Is each attribute related to a specific method? Could we link each attribute to a specific method?
Is what?
Is it a good practice to link any attribute with a specific method?
We will see that later. That we're going to create methods are called setters and getters. And each one of those methods and setters and getters are going to be linked to those attributes.
Okay.
But again, one of the things they should know that those methods here, they simply have access to those attributes, so they can use them if they need them.
Oh, no, I understand. Okay.
Okay, so now that we have an idea, now by the way, here I'm just talking in general here. I didn't get into how exactly this is possible and how do we put this in action. I'm just talking about the concept here. And if the bottom line, what I'm trying to get out of this here is that I want you to understand one simple concept, which is object-oriented programming is all about creating classes. And from the classes, we create objects. I'll give you one very basic example. And let's take the Word that you see here, the Microsoft application Office Word. You can see here, I have buttons, a lot of buttons here. There's a part in this application that you see here, a class called button. And in the button, we're simply describing buttons in general. Their shape, their size, the background color. But every single button, for example, looks different than the other ones. So those are the attributes that hold different values. And then when you click on each one of those buttons again, well, in this case, most of these buttons will perform something different. And this is something related to inheritance, which we're going to talk about later So I think this is not a good example to start with. But in general, what I'm saying here is that this program that you see here, the Microsoft Word, is object-oriented programming. Everything you see here are simply objects. Every button here is an object. Okay, the text field here that I'm typing is an object. The drop-down menu that you have, we don't have drop menu anymore in Microsoft. But again, these are, again, those tabs are objects. And there is a class that actually is part of this program where it describes all these objects, and then after that you generate those objects and you put them in the layout that you see in your monitor. So before me going into how do we create classes, which I'm going to go into later today, I just want to go through 5 important concepts related to object-oriented programming. And believe me, those are the type of questions that you will be asked in interviews. And let me just, since I mentioned interviews, usually with interviews for programmers, they start with the basics. And those are the basics that I'm going through. After you pass the basics, they move on into data structures and algorithms, which it gets a little bit more complicated. This is something that's far away from our level at this point. So we're going to put that on the side. We're just going to focus on the basics. So object-oriented concepts are simply 5. And I'm going to go through them now just to give you an idea here. And it's a good idea, actually, to understand those concepts. So first of all, encapsulation. Encapsulation, what is the term encapsulation simply means? Encapsulation is the process of us putting everything that we know about a class into one unit. For example, if you go back to the example that we had before, we were talking about a smartphone. We talked about the attributes and we talked about the methods of a smartphone. And if you take the attributes and you take the methods and you put them all together in one unit, that is what we mean by encapsulation. Now, in addition to that, encapsulation also involves hiding the internal details of the objects from the users. So what is that supposed to mean? And the second point here is access the data is controlled using access modifiers, or in other words, it's controlled by you, the person who created the class. So let me just go back into those 2 points to explain them in details. So encapsulation in general simply means putting all these attributes and methods together into one unit to produce one object called a smartphone. Now, if we don't have object-oriented programming, I will have a single program with all these attributes and all these methods, and they're just going to be distributed and they're everywhere. And if I want to create multiple objects, then I have to have multiple colors and multiple attributes, which again, we're not doing that. That's not the right way to do it. So back to the encapsulation, the fact that I can actually put a group of attributes and group of methods under one unit, that's encapsulation. Hiding details. I want to give you an example here so you understand. Imagine you want to buy a car. And the car by itself is an object that somebody created. And when you buy a car, the job of the person who's selling you the car is simply to tell you, for you to be able to run the car, just press on this button. Very simple, very easy. But here's the thing. You know, and I know that there are a lot of complicated mechanical operations are implemented inside the car to make the car start. But for us, we really don't care about these details. All we care about is, how can I use this car as fast as possible? And the answer was simply by pressing the button. What the manufacturer did here is simply they hide. They hide every single detail from you. They don't want you to worry about these details to be able to use the car. They simplify it to a point where it's a matter of pressing a button. And that's simply what we mean by hiding the internal details about your class and objects. Accessing the data, just like how, as I said, the color properties in a smartphone. When you want to buy an Apple product, the Apple 15, for example, comes with 4 colors. So when you're going to go and buy a phone, an iPhone, Even though you think you have the choice to choose the color you want, but in reality, you're not the one who control what color you get. It's what Apple decide. So all these data is simply going to be controlled by you, the person who created the class. And that's simply what we mean by encapsulation. Inheritance is the fact that I can create classes with a relationship of parent-children type of relationship. So what is that supposed to mean? Let's just take this example. Imagine you want to create a video game about zoo. And in this zoo, you decided that you're going to have a lion, a tiger, a wolf, an elephant, a giraffe, a shark in this zoo. So you're going to go to each one of those objects and you're going to start creating classes for them. But at a certain level, you will realize that, well, all of them goes under one big family, which is an animal. They are all animals. So you would notice that they share a lot of properties and they share a lot of attributes and methods. For example, they all breathe. They all move. What else? They all eat. So instead of you repeating eating and breathing and moving in each one of those classes individually, what you can do, you can create a more generic class called animals, and then let the other classes, the subclasses, inherit from the parent class. Now, this again is called inheritance. This concept by itself is important to not redundant, keep repeating the same code here and here and here. That's not acceptable. So whenever you feel like you're doing something repeatedly, you should know that you're doing it wrong. It will be much better if you create a super class and let the other children or parent class and let the children inherit from that super class. This is simply what we mean by inheritance. And it's a relationship between classes. So that's very, very important. Polymorphism, which is one of the most complicated concepts in object-oriented programming. I just had to stand a little bit. My foot is hurting me for some reason. So polymorphism, what is polymorphism? Polymorphism, the word by itself simply means multiple forms. And the concept of polymorphism simply means that you can have an object and that object can change the way it implement the methods depending on the situation that object is in. I'll give you an example here. I'm an object. I'm a human. One of the things that I can do is speak. And now that I'm talking to you, I'm speaking English. But when I'm going to go and talk to my wife, I'm going to be speaking with Arabic, for example. Now pay attention to here. It's the same object that's performing the same action, which is speaking, but the way I speak is going to be different depending on the situation that I am in. So when I'm speaking to you, I'm speaking using a specific language. When I'm speaking to my kids, I'm going to be speaking in a different language. When I'm going to speak to my wife, I'm going to speak with a different languages, and so on. So you can see here, it's one object that can perform one specific operation or method, but the way it's implemented varies from one place, from one scenario to the other. And that's what we mean by polymorphism. It's implemented, it's doable, and it's very, very interesting concept.
So I have a question.
Yes.
Is the object doing multiple methods, or is it one method that changes?
Oh yeah, here's the thing. The way it's implemented, it's going to be, again, we're not going to go in this class. This is a little bit advanced. But just to give you an idea, here's what we're going to do. We're going to create, let's say, a generic class called a human. In the human class, we're going to have a method called speak. And then from that, I'm going to create multiple objects. One of them is called a teacher, and one of them is called a husband, and one of them is called a father. And as you can see, a teacher and a husband and a father, three of them are a human being. And a human being can speak, and a teacher can speak, and a husband can speak, and a father can speak. But the way each one of those speaks is different. And what I'm going to do, I'm going to change my personality depending on the situation that I am. So I'm going to start by creating a class called a human. And then as a human, I'm simply going to be switched to be a teacher. And then after that, I can switch to be a parent. And then after that, I can switch to be a husband.
Okay.
Okay. Here's another example. Have you guys seen the movie It? Anyone? Yes, no?
No.
Pennywise.
Yes.
Pennywise is a perfect example of
Yeah.
polymorphism. Because to start with, it is an it, which nobody knows what it is. It's an it, but it takes many different forms. And those forms simply has one goal is to scare the kids. But the way he scares the kids varies from one object to the other. It's the same object, but the way he's appearing, the way he's performing the scaring varies from one point to the other, depending on what that child is scared of. It is a perfect example, by the way, for polymorphism. Because if you think about it, it's the same thing. It's not multiple objects. It's the same object. But that object, one time he's a sick man. The other time he's like a clown. The third time he's what else? He's a spider. So you can see he changed his form depending on the situation that he is at. And he's simply performing the same action. He's trying to scare those kids. But the way he scared those kids varies from one point to the other. Abstraction. What is abstraction? Abstraction is very important. And abstraction simply means when you're going to start creating classes, you really need to simplify it to the max. For example, let's say I'm creating a class about a teacher. And a teacher is a human being. So for example, let's consider me as a teacher. And we're creating a simulation software about a program that will evaluate my performance in this class. So when it comes to me, you can think about many, many properties and behaviors that I can do. For example, I can swim. Now, let's talk about swimming, for example. Is swimming has to do anything with the fact that I am a teacher? And the answer will be no, it has nothing to do with it. Whether I know how to swim or I don't know how to swim, that has nothing to do with the reason why I'm creating this program to evaluate my performance as a teacher. So it doesn't make any sense to include a method called swimming inside the teacher class, even though a teacher can swim. But the question is, will swimming have any effect on the reason why we're creating this class? And the answer will be no. So you don't have to put it there. Let's say, what else do I have? Let's say my weight. I don't know if my weight should be doing anything with the class. So do I have to include that when I describe a teacher, his weight? Maybe this is an argument like subject, but I will say no, it has nothing to do with his ability to teach or not. So you can think about when it comes to creating those classes, there are many, many attributes and many, many properties and many, many methods you can think about that's related to that object. But the question is, are those attributes and methods related to the reason why you're creating this object? And if the answer is no, then you don't do it. You don't put them there. And that's simply what we mean by abstraction. Just make sure you only list them, implement the properties and the behaviors that has to do and related to the reason why you're creating that object in class. Now, association, it's the way that it's a type of relationship between classes. And I'm going to give you that relationship in a lot of examples. For example, you as a student, you have courses. So a course is an object and you as a student is an object. And there's a relationship between you that you have a course that you're taking. I have a smartphone. I'm an object. The phone is an object. And that's the relationship that we have between them. So objects are related to each other somehow using this technique. Sometimes one object can have another object as a member inside it. So me, I'm an object, and I have another object, which is a smartphone that belongs to me. Just like when we talked about the colors, for example, or religion or name, those are properties that describe the teacher, but at the same time, the teacher, in addition of the teacher has a name, the teacher also has a smartphone, and the smartphone by itself, it's an object of another class. And that's what we mean by association. So the bottom line here, in the future, if you're going to go for a job interview, and that job interview is for software development, I will guarantee you will be asked for 3 at least of those 5. And this is going to be the first threshold that they will know how good you are with object-oriented programming and if you understand them. Now, of course, this is not everything. There's something called interface. But as I said, this is, again, something very generic and something basic. You'll have a whole dedicated class in the future just to describe and to see how can I implement all of these concepts into classes. For now, we just need to have an idea about what they are. Okay, so are there any questions? Let me move on. And what I'm going to do here, I'm going to take this smartphone and try to show you how do I put it in a class in reality. And next class on Thursday, I'm going to go to the PowerPoint and go with the points in the PowerPoint, and I'm going to try to project them on the smartphone class that we have here. So let's go straight to, where is it? Here it is. Okay, so first thing first, I created a project called Chapter 6. And in Chapter 6, I created the main class. And here's my main class. So nothing new. We already know how to do that. Now, here's the new part. I'm going to create a class called Smartphone. So I'm going to right click on Sources, New Class. And this time I'm going to call this Smartphone. Pay attention to this part. Never have a main method in your class Smartphone. Why?
Wait.
Yes? Oh, you can't see it. You can't see it. Okay.
Yeah, can you do that again? I didn't see it.
Okay, let me just cancel this part. Cancel this part. You go back to right-click on the sources, new class, a new window will pop. Let me just share it. You'll see a window like the one that I see here, and you give it a name. I'm going to call it Smart Phone. And this is not a camel case, by the way. The first letter has to be uppercase. And make sure you don't choose a public static void main method here. So don't click on this checkbox here. Once you're finished, let me go back to Eclipse. You will see that you have a new class. So you see here, I have 2 Java files. The first one contains the main method. The second one has no main method. This is my smartphone class. Let's look at the smartphone class. It has a header and it has a body. The body starts with the open curly brace and closing curly brace. And the header starts with the keyword public and the keyword class as a definition. This is we are about to create a class, and the class called Smartphone. The name of the Java file should match the name of the class. It has to be public. Otherwise, it's not going to be usable. Why it has to be public? Because later I'm going to go to the main method here, and I'm going to try to use the smartphone that I have here. So if the smartphone is not public, then I will have no access to it here. Now that I created my smartphone class, I'm going to break it down into 2 sections. The first section is called the data members. And the second section is going to be called method members. So those are my 2 sections. Data members and method members. Now, data members, this is the place where you put all the attribute and properties. You list the attribute and properties. The method members is where you list the actions, the behavior of the smartphone. So let's start with the first one. For simplicity, I'm just going to go with 5 attributes. So I will start with a string. And then I'll put color and put semicolon. And pay attention that I haven't assigned anything to those values. And I will create another string. I will call it a brand. And I will create another string. Let's create a double. We'll call it price. I forgot that part. So it's a color, it's a brand, it's a price. And I'll create another string. We'll call it phone number. Phone number. And let me just change this to a lowercase p. And let's think about a 5th one. So we got the color, brand. Let me go back to that file. See, color, operating system, so there's no brand, storage. Let's go with the storage. And here we go. So double, or not double, let's go with integer. Storage. Lowercase s. Let's see here. So this is what we have. Where am I? Let's go back to. So here we go. These are my attributes. Now, one thing that, I have to explain here. I need to tell, and I want you to pay attention to this because this is extremely important. I need to specify, are those data members are going to be private or public? And this is extremely important to pay attention to. Should I go with public or should I go with static? Let me just, private. Let me tell you what's the difference between private and public. If I come here and type public, okay, let's go with public, all the way public. So V. And by the way, just to give you an idea, this is a question that could be asked in an interview. If you don't specify if it's going to be public or private, by default, Java will choose private for you. So it's important to understand that point. So this is my data members. I decided that the color and the brand and the price and the phone number and the storage are going to be public. Now, my choice here is wrong and is not acceptable. And let me just show you why is that the case. If I come here and say smart phone, and I will call it my phone. So here I am. I created a phone. It's my phone. Let me just come here, copy that, and put it here, and put color, and set the color to be red. Now, immediately, he's complaining about something here. And he said, my phone is not initialized. So if I try to initialize it, this is how we do that. He's still going to complain, I believe, about something. No, actually, he didn't complain. And here it is. So this is, again, how do you create an object? Remember here, you created the class here, and you come back to your main method, and you create a phone like this. So a smartphone, my phone, you can call it whatever you want, equal a new smartphone with open parentheses that are empty. I'm going to explain this, of course, later. Let's create another phone. And then the second phone that I'm going to generate is called your phone. So you got your phone and my phone. And I decided that my phone is going to be red. Your phone dot color is going to be green. Semicolon. And you, let's see, why is he complaining? Did I misspell anything? Yep. So here we go. This is my phone, which is red, and your phone, which is green. Now, the thing that I'm doing here is unacceptable. Why is not this is unacceptable? For a simple reason. Those are data members of the class. And by generating them and creating them as public, I'm giving the user a full control over whatever color the user want to use. Remember here, this is the place where you can play and you can work, and this is where the user will be working. So a user here can come and decide the color that I want to go with is simply this. That should not be acceptable. So by defining, let's go red again, by creating those attributes and deciding to go public, you're giving the user a full control over what values are going to be assigned to each one of those phones. And that's against what object-oriented programming stands for. So what we like to do, we simply come here and change those to private. So look what's going to happen after I change everything to be private. Control C. And V. And that's again what you should be doing. Never, ever assign or use a specifier for a data member to be public. It has to be private. So you can see here it's private. And now he's complaining. He said, the field smartphone color is not visible. You don't have access to it. So this program will never execute because I decided that those data members are private and you as a user should never have a direct access to it to change it the way you want it. Now you may ask a question, well, how do I change those values then? Well, we have our own way to get that done. And we are going to talk about that, of course, later. Let me just continue with what we have here. So let's say here, let's go back here. What I do have here is that I created two phones. One of them is my phone and the other one is your phone. Well, you need to understand that my phone has a color, my phone has a brand, my phone has a price, my phone has a phone number, my phone has a storage. Same thing, your phone has the same properties. But what are the values at this point? We don't know what the values are, and we're going to figure that out later. So let's go to the data methods, or sorry, the method members. Now, if you go back to the document, we said we have 5 methods, one of them to make a call, text. So I'm going to copy them from my document, which I know that you guys are not seeing that right now. Let me go back to, where is Eclipse? Here it is. Come on. Okay, I think now you can see it. I'm just going to put it down here in the form of a comment. So those are my methods. Methods, on the other hand, must be public, at least at this point, because if they're private, you cannot have access to them here. So we're going to go with the first one. It has to be public. Now, when you make a call in your phone, what will be the final results of making a phone? I can think about it as, have you successfully completed the call or you failed to successfully complete the form? So you have two choices. It could be true, could be false. If you are able to make the call all the way to the end and terminate the call at your end, then that simply means it was a successful phone call. So I can put here Boolean as a return data type. After I'm done with the call, I am simply getting true as an indication that the phone call was implemented and was completed successfully. Now, after I decided that the phone is going to be public, it's going to return Boolean, I have to give it a name. And in this case, we're going to go with a camel case. Make voice call. So that's the name of the method. After that, you open a parenthesis and you close it. And then you open a curly brace and you close it. And this here is simply what we call a method or behavior. Now, let's just talk about this method by itself. The method simply contains the signature or the head of the method and also contains the body of the method. Now, the body of the method, this is the place where you're going to start writing a code of how exactly a phone will make a call. Now, let me ask you a question here, which is very, very important. When you want to make a call, what is the most important piece of information that you need to be able to make a call? And I'm waiting for you to tell me what it is. You can type if you want. If I want to call somebody, what do I need to be able to call?
SIM card.
I would say yes, but I'm not looking for the exactly numbers. I need to know that person that I'm trying to call. So what I'm going to do here, this is where you put the information that you need for the whole operation to be completed. So if I want to make a voice call, I simply need string for we'll call other phone number. Or maybe I'm going to be calling another phone. So I can just put here, instead of a phone number, I can put a smartphone as an object. This is what we call a parameter, by the way. So for me to be able to make a voice call, I need to know the other phone number that I'm trying to get called. Now I'm just going to put a comment here. I'll say this is where you write in detail the code of how exactly you can make a call. Now, of course, I'm not going to go through that because this is not our job here to write a program to make a voice call. But I'm just going to come here and say system.out.print line, and I will just say calling, and I'll put the smartphone, other phone number here. So just remember here, this is just a demonstration. So I just want one single line to be executed. Now, after that, I'm going to assume that the phone was actually completed successfully. So I'm returning true. These are just assumptions. Now, what do you have here? Simply, again, goes back to exactly how a voice call will be made. And this is out of the scope of the class that we're covering right now. So this is, again, one of the methods. Now let's talk about texting. Has to be public. And again, a message could get to the destination or could not. So I'll say text. And just like how you needed to run to make a call, you need a phone number. So we're going to put the phone number here. And I'm just going to put a comment here. And it's going to be exactly the same. This is where you're going to type. Remember here, you don't have to type anything. You can text. And then after that, I'm just going to come here and I will just put a system print message and return true, assuming that the text actually got to the destination. And I'll just say texting the other phone number. Now, of course, the same thing will be applied for a video call. So we'll just make a video call. And this is where you're going to make a video call. And I'll just come here. FaceTime. Call. I don't know if Android call it FaceTime. I know it's an Apple thing. So I'll just call it video calling. That's the third one. The fourth one is taking a picture. So I'm going to go public again. I will put void as nothing is returning from that part. Or could return a picture, but let's go with void. And we'll just say take photo. And I'll just say, this is where you put the detail, the code of how exactly you can take a photo. photo using the camera. And we'll just put a message again. And let's put it here. And we'll just type, for example, smile or camera app is running. Nothing's going to be returned because it's a void. Void simply means by the time the program is executed, nothing will be simply returned. And by the way, once I'm done with this, I'm going to create another class example called a calculator. And a calculator is going to be very simple, way more simpler than this application. You will be able to see some action taken by those methods. Finally, we have a run app. So I'm just going to copy this here. Also going to be void. We'll just call it run app. And of course, I have to pass, for example, what is the name of the app? So app name, details how to run an app. And here I'll just say app, and I'll just app name plus is running. And it's not returning anything. So here we go. Those are the apps. Those are the behaviors or the methods that we have. We have 5 of them. And those are the attributes. And this is how we create class objects. You start with the name of the class, the name of the object equal new, the name of the class, and the parentheses. Now, the parentheses is something we're going to cover in details next class, to talk about what exactly I'm supposed to put here and what exactly this line simply means. But at this point, all you need to know is that this application here, this lines of code is simply creating objects. Now, if I want to have access to any of these methods that you see here, all I have to do is to do the following. You come here in your main method and type the name of your object, for example, my phone, dot, and then you call the methods that you have here. For example, text. Let's see, why is he complaining about this? Oh, I have to put a number here. So I'll just go 816, 816, then 8166. Okay, and let's choose your phone, for example, to make a call. So your phone dot make, what did you call it again? Make voice call. And I'm going to pass a different phone number. In this case, I'll go with 913-913-9133. Now, if I run it, look what's going to happen. It's telling me, texting the phone number that I typed, and then the second one is calling that phone number. You can see here each one of those methods. Again, each one of those objects that I have here is simply going to be associated with all these variables and all these methods, and you can have access to those those methods. Since they're public, you can have access to them here by simply typing the name of the object, the name of the method, and then you pass the parameter. And remember here, this is very important. This string here is simply going to be passed to the other phone number, which is going to be used here. And that's why you saw it printed here. Same thing here.
Question.
Yes.
Is this like creating modules in Python then?
Somehow, yes.
Okay.
Mm-hmm. This here again, your phone, I'm calling the make voice, and I'm passing this phone number here, and it's going to be passed to the other one I call the text, sorry. This one I'm calling the voicemail. So I'm passing the number to the other phone number, and it's simply going to be printed on the screen. So at this point here, I'm going to stop. And next class is going to be all about dedicated on so far, what are the values of these elements here? So what is the color? What is the brand? What is the price? What is the phone number? What is the storage? I didn't specify anything when I created those objects here. So how do I assign values to those attributes? That's what we're going to be covering next class. Is there any questions that you guys may have? Nope. Okay, so let me just stop sharing this part, and I'm going to go to the PowerPoint. Let me see here. Share the PowerPoint. So this is, again, the objectives of this class. Object, classes, encapsulation, which we covered. UML, we're going to talk about it later. OOP, first class. Private versus public, I showed you guys that. Here's an example of a driver class. Reference variables and instantiations, calling a method and calling an object. So most of these topics here, we covered most of them in general. And next class, we're going to go and, oh, here, still, I forgot that we still have this. The keyword this, we're going to cover it next week. Default values, we're going to cover it next week. Variable persistence, we're going to talk about that. UML classes, diagrams, local variable, return statements, void. We talked about those two today. Empty return statements, we're going to talk about that. So argument passing and the accessors, which is setters and getters. So all of these elements that are left here simply will be covered on Thursday. So stop sharing. And if you have any questions, please let me know. Otherwise, we are done for today.
Thank you.
Thank
You're
you.
welcome. You're welcome.